This is the second video covering adding and subtracting rational expressions that I'm making. In the first video, I focused on how to add and subtract once you already have a common denominator, because these things are just fractions. This video is going to focus on how to get those common denominators, which is going to make these questions a fair bit more difficult. So let's just go straight into it. So let's say I wanted to add two fractions without any variables, just typical fractions, like these, 3 over 4 plus 5 over 6. So they do have different denominators. So just a quick refresher, to get a common denominator, this is something that I'm going to guess most of you have a pretty good handle on. All we need to do is multiply either one or both of our fractions by something to make the denominators match. So in this case, if we want to make the 4 and the 6 match, we got to think, well, okay, what number do 4 and 6 both go into? For those two numbers, we've got options. You could use 24 or 36, but the best option is the smallest one, which is just 12. So to turn my 4 and my 6 both into 12s, I'm going to multiply my first fraction by 3 and my second fraction by 2. So 3 over 4 is going to become 9 over 12, and 5 over 6 is going to become 10 over 12, which, once we add them together, just becomes 19 over 12. So once you reach this point, this is just the same thing that we did in the last video. We already have the common denominator. So really the only thing we need to know how to do when it comes to our rational expressions is just getting those common denominators. So let's try a few out. So let's say we had 5 over x plus 7 over 2x. So again, the denominators don't match. We need to multiply one or both of them by something to make them match. And so the standard that you can always go to is just to multiply both of the denominators together, right? So multiply the first fraction by 2x, multiply the second fraction by x, and that will work, but it's not always going to be the most efficient option. So we really just want to multiply them to try to get them to be the same. And what we can do is just multiply the first fraction, in this case, by 2. So when we do that, the 5 is going to become a 10, and the x is going to become a 2x, which will make it match with the second fraction. Now once we add those, 10 plus 7 is just going to get me 17 over 2x. If we could, we'd simplify this, but we can't, so we just leave it here. And we get an NPV of x can't be 0. Looking at something pretty similar, if we have 3 over x squared plus 2 over 5x. So now, to make these match, we do have to go a little bit further. So the first fraction is missing a 5, right? We've got x's, but we don't have a 5. So we're going to have to multiply that first one by 5. The second fraction has a 5, and it has an x, but it's only got one x, and it should be x squared. So to make that match, we're going to multiply the second fraction by x. And so what we end up with is 15 over 5x squared and 2x over 5x squared. And so we're going to add those together as much as we can. We can't actually combine anything, but we can at least write them as one fraction. This becomes 2x plus 15 over 5x squared. We can't factor anything. We can't simplify anything. So it's really just going to stay there. Most of the time, our fractions are going to be a little bit more complex than that. So let's try something a little bit tougher. So if we have 2x over x minus 4 and 5 over x plus 1. So the key thing to remember is that these two factors here, these two denominators rather, these x minus 4 and this x plus 1, even though they both have an x in them, these are totally different factors. There is zero crossover here. This is like comparing a 5 and a 13, right? There's nothing that goes into them. Or let's say a 13 and a 17, where they both have a 1 at the start, but that doesn't actually mean they have anything in common. So to get our common denominator here, which we're just going to do over here on the side, our common denominator is actually just going to be those two things multiplied together. X minus 4 times x plus 1. And that's how it's going to work for all of these. So every factor is completely unique, unless you can take out a common factor to make things match. But once everything's been taken out and broken down as much as possible, That's all this is. So now we just need to make both of these fractions have that common denominator. So my first fraction of 2x over x minus 4, it already has the x minus 4, so it's great on that end. But it is missing the x plus 1. So what I'm going to do is I'm going to take that first denominator, and really that entire first fraction, and I'm going to multiply it by x plus 1, so that it'll have both of the factors from my denominator, right? So it already had the x minus 4. That part was good. Now, because I've multiplied by x plus 1, it also has the x plus 1, and so it has everything it needs. We're going to do the same thing for our second fraction, so our 5 over x plus 1. It already has the x plus 1, so it's good on that end, but it's missing the x minus 4, so I'm going to multiply this whole fraction by x minus 4. And so now that I've done that, it is also totally fine, and it has everything it needs. So normally I wouldn't do this, just to kind of set up how this is going to work and just refresh you on things. So 2x times x plus 1, I'm just going to do it over here on the side. So we've got 2x over x minus 4 times x plus 1 on the top and the bottom. We're not going to multiply out the denominators, right? So we want those to stay in factored form so that we can cancel things out later. So we're just going to leave that as x minus 4 times x plus 1. But we do want to multiply out the numerator, because if we're going to combine like terms here, because remember the whole goal is that we are doing addition. So if we're going to be able to add these, we need to be able to get like terms and put them together. So we're going to multiply out the numerators, which in this case means we're going to have to distribute. And we're going to get 2x squared plus 2x. We're going to do the same thing with the other fraction, so our 5 over x plus 1. That's going to get multiplied by x minus 4. And so if we distribute there, we're going to get 5x minus 20, also over x minus 4, and x plus 1. So going back to our original question then, once we've multiplied out both of those, we now have 2x squared plus 2x over x minus 4 times x plus 1 plus 5x minus 20 over x minus 4 times x plus 1. And so now this is just the same thing that I had in my first 6.3 video, because we've already got common denominators. So we're just going to add these together. So I've got 2x squared. 2x plus 5x is going to get me 7x. The 20 is just a 20. And my denominator is x minus 4 times x plus 1. At this point, I would now try to factor out that numerator. I'll just tell you it's not going to factor, but we should at least try to if we could. So this one is just going to stay as is. And then we need to do some NPVs. We've got x cannot be positive 4 or negative 1. And so this one's done. All right, trying another one. And so in this one, I'm going to kind of break down the steps very clearly, bit by bit. So if you're going to take notes on anything, this is definitely the one you want to follow along with. So, general rule of thumb for pretty much any of these questions. Step 1. First thing we need to do is factor our denominators, because we need to know what's in those denominators so that we can make them common. So our first denominator is going to factor to x minus 2 times x minus 4. Our second denominator is going to factor to x minus 2 times x plus 1. Step 2. Now that we've factored our denominators, we need to figure out what our common denominator is. So before we do that, I'm just going to slide over to the side here and just kind of give you an example with easier numbers. So if we had 1 over 6 plus 1 over 10, and I wanted a common denominator for that, I think most people would be able to figure out that the best common denominator for 6 and 10 is probably going to be 30. So if we break these things down, 6 is 2 times 3, right? 10 is 2 times 5, and 30 is 2 times 3 times 5, right? So this is that prime factorization stuff we did back in chapter 5. And so if you look at this, you can see that both my denominators had a 2, and my common denominator has a 2. One of my denominators had a 3, so my common denominator has a 3. And one of my denominators had a 5, so my common denominator has a 5. So anything that pops up in either of your denominators, or any of your denominators, because you might be doing more than 2, has to appear somewhere in your common denominator. That's the only way to make these things match. So if we look at what we had here, both of my fractions have an x minus 2. So I know my common denominator is going to have an x minus 2. But it doesn't need to have 2 of them. It only needs to have 1, because if it has 1, it already has kind of fulfilled that x minus 2 requirement for both of my regular denominators. It also needs to have an x minus 4, because my first denominator had an x minus 4 in it. So right now, it already has completely matched exactly what I had in my first denominator, right? So x minus 2 times x minus 4, done, perfect. But it doesn't match the second one yet. So if I go to my second fraction, I still need to have an x plus 1. And so that gets me this. And so if we look at this, I've got x minus 2 times x minus 4, and I've got x minus 2 times x plus 1, right? So if I just completely take out that x plus 4, we can see that entire second denominator is represented as well. And so this is my common denominator. It's just any factor that appeared in any of the denominators put together. Now that we've got that common denominator, step 3 is going to be to multiply each fraction by whatever's missing from its denominator to get that common denominator. So only by the factors that are missing. Which is why it's so important to be really careful getting that common denominator and to not include too many things. Because if you include too many things, if we had included, say, an extra x minus 2 here, it wouldn't necessarily have been mathematically wrong, but it would have meant that we would have been multiplying by too much stuff, and it would have made this really just way too hard for us to deal with. So, looking at what we had x over x minus 4 times x minus 2. And so this is missing the x plus 1, so I'm going to multiply this fraction by the x plus 1. My second fraction had the x minus 2 and the x plus 1, but it's missing the x minus 4. So this fraction is going to get multiplied by x minus 4. And so if you look, these denominators now, they're written in slightly different order, but they are the same. They all have an x minus 4, an x minus 2, and an x plus 1. And so we're happy with that. We've got a common denominator in both of our fractions. Step 4 now, we're going to expand, which just means multiply, the numerators, but not the denominators. So I'm going to do x times x plus 1, which is going to get me x squared plus x over that common denominator of x minus 4 times x minus 2 times x plus 1. And then my second fraction of 3x minus 12 over that same common denominator of x minus 4 times x minus 2 times x plus 1. And now we have common denominators, so we are at the point where we're ready to add. So last step is going to be add and simplify, if possible. So we've got x squared, which is just x squared because we've got nothing to combine it with. X plus 3x is going to get me 4x. The minus 12 is just going to stay as a minus 12. Then we've got that denominator of x minus 4, x minus 2, and x plus 1. We're going to factor out whatever we can up top. So the numerator is now going to be x plus 6 times x minus 2 over x minus 4, x minus 2, x plus 1. And so we do have that repeated x minus 2 that we can cancel. And we're left with our final answer of x plus 6 over x minus 4 times x plus 1. For NPVs, we've got 4, -1, and 2. And so there you go. That's how you deal with non-common denominators. You can see, compared to what we did in the first 6.3 video, there's a lot more going on here, right? So these questions become way more complicated and way more time consuming just because getting the common denominator takes a lot of work. And you've got to be really, really careful with your factoring, with your multiplying, with your adding, with your more factoring, or else things are going to go wrong and you're not going to be able to simplify, or you're just going to get completely wrong answers. So let's try another one. So we're going to have x plus 4 over 2x squared plus 12x plus 18 minus 4 over x squared plus 7x plus 12. So if I factor that first one as much as I can, I'm going to get x plus 4 over 2 times x plus 3 times x plus 3. The second one is going to get me x plus 3 times x plus 4. So our common denominator, remember, it has to include everything that appears in either of these fractions. So I think everybody will probably agree that we need at least an x plus 3 and an x plus 4, but we actually need two x plus 3s here. The reason for that is because our first fraction has two x plus 3s in it. And so if we're going to match that fraction, if that entire fraction is going to be included in this common denominator, we do need to have two x plus 3s. And so this is the only time you have to include duplicate factors, is if one of your fractions already has a duplicate in it. On top of those x plus 3s, we do need an x plus 4 to match the second fraction. And then there is one more thing we need, which is that 2 that we had in our first fraction. So this 2 down here gives us this 2 right here. Now that we've got our common denominator, let's put these fractions over that common denominator. So we've got x plus 4 over 2 times x plus 3 times x plus 3. And so this fraction already has the first 3 bits of our common denominator, but it is missing the x plus 4. The second fraction has an x plus 3. It has an x plus 4, but it's missing two things, which is new for us. It's missing both the 2 and the x plus 3. And so that is a tricky thing to deal with. People often multiply these wrong in cases like that, so I'll get to that one in a sec. Let's just worry about the first one first, because it's a little bit more what we're used to. So if I multiply x plus 4 and x plus 4, that's going to get me x squared plus 8x plus 16. So when you're looking at this, there's something that you're going to have to remember to do, and that is FOIL. So remember, you're doing x plus 4 times x plus 4. You are going to FOIL that, or else you're going to get this wrong, which is where that x squared plus 8x plus 16 comes from. Our denominator is now 2 times x plus 3 times x plus 3 times x plus 4. For our second one, so 4 times 2 times x plus 3. I'm just going to slide over here for a second. So we're doing 4 times 2 times x plus 3. A common temptation here, especially after just FOILing, is to take this 4 and to distribute it through, but that's not how multiplication works. So if I just asked you to do 2 times 3 times 5, you're not going to go and sit here and say, okay, that's 2 times 3 and 2 times 5, which is going to be 6 times 10, which is 60. That's wrong, right? How most people are going to do this is they're going to say, okay, 2 times 3 is 6, and then 6 times 5 is 30, and that's the actual right answer here. So when you're multiplying, only multiply one thing at a time. And as a general rule of thumb, multiply anything that's outside of your brackets first. If you have two sets of brackets, which we'll see later, multiply those. And then only once you've done all of that, do you combine any coefficient that's outside of the brackets with any polynomial that's inside of your brackets. So in this case, I'm going to do 4 times 2, and that's going to get me 8. And then I'm going to worry about the x plus 3 after that. So I've got 2 times x plus 3 times x plus 3 times x plus 4. So putting these together, and I'm going to maybe save myself a little bit of work here and write these just as one fraction now so that I don't have to write out that denominator twice. We've got x squared plus 8x plus 16 minus that entire second thing of 8x plus 24. So to get there, I distributed that 8 through. And then all of that is over 2 times x plus 3 times x plus 3 times x plus 4. Okay, we've got a common denominator. We can combine some like terms. So x squared is just x squared. 8x minus 8x is just going to cancel out. 16 minus 24 is going to get me negative 8. And I'm left with that denominator. And this, there's not really any factoring I can do, at least not any useful factoring. There's not any simplifying I can do, so this one's done. Other than our MPVs, which are x cannot be negative 3 or negative 4. Don't write out negative 3 twice, right? So yes, we do have two x plus 3s down there, but they don't give you like duplicate NPVs. Everything only comes up one time. So there we are. All right, let's make this a little bit trickier. We're going to add a few extra fractions here just to really bump this thing up a bit. So we've got x over x plus 2 plus 5 over x plus 6. Right, so pretty simple. We don't have anything to factor right now. These ones both look pretty good. But then we're going to have 3x squared plus 22x plus 24 over x squared plus 8x plus 12. And then, just to make it a little bit more annoying, plus 2 at the end. So one thing I will say, in this particular case, this one's going to work out fairly nicely. There are going to be cases, especially potentially in your textbook, where they are going to expect you to look at something like this third term here, factor it first, simplify it, then come back and do your adding and subtracting and all that. I'm not expecting you to do that generally, especially not in this case, but just do know that there are questions that are like that exist. So if you get one where your common denominator seems too complex and you've put everything over that common denominator and you ended up with cubes or powers of 4, chances are they expected you to go back and cancel something out to get rid of some of your factors to make things a little bit easier. In this case, though, we're not going to have to worry about that. So if I factor that first term, instead of having an entire step of just your factoring like we did here, what I'm often going to do is I'm just going to factor just underneath here, and I'm going to get x plus 2 times x plus 6 just to save myself a little bit of space. And so if we look at this, my common denominator is actually a lot simpler than you might have expected from this question. We need to have an x plus 2. We need to have an x plus 6. But that's actually all we need to have, because my third fraction there is just x plus 2 times x plus 6, so it's already represented. And my fourth fraction doesn't even really have a denominator, but if we wanted to give it a denominator, it would just be 1, and 1 doesn't really matter for this. All right, let's try to make our lives a little bit easier. I'm going to combine these all directly into one fraction now, so I don't have to write out that common denominator 4 times. So my first fraction, the x over the x plus 2, is missing x plus 6. My second fraction, the 5, is missing x plus 2. My third fraction doesn't need anything, so it's got both parts of that. So it's got it's got the x plus 2, it's got the x plus 6. We do need to subtract it properly, though. So it's going to be minus 3x squared plus 22x plus 24. And then my last fraction is missing both things, so the x plus 2 and the x plus 6. So I'm going to need to multiply it by both. And then all of that is over my common denominator of x plus 2 times x plus 6. All right, so we've got some multiplication to do. So x times x plus 6 is going to get me x squared plus 6x. 5 times x plus 2 is going to get me 5x plus 10. If we get rid of that bracket here, remember we're going to have to subtract everything. So this is going to become minus 3x squared minus 22x minus 24. And then at the end here, this is something that people, again, are going to do wrong. You're not going to take this 2 and distribute it through with everything. So it's the same thing I was talking about up here. You're going to do one multiplication at a time. And for this, you're going to start by foiling. You don't have to. You could start by doing, say, 2 times x plus 2. But in my experience, your best bet is to multiply the stuff in the brackets first, and then to worry about that 2 afterwards. So when we do that, we end up with 2, and then x squared plus 6x plus 8. So we do need to do that last multiplication before we can fully combine these. You could start combining some stuff now. I'm going to do the multiplication first. So we're going to have x squared plus 6x plus 5x plus 10 minus 3x squared minus 22x minus 24. And then now we're going to distribute that 2 through. And so this is going to become plus 2x squared plus 12x plus 16. Oh, and actually, you know what? I messed up somewhere. Mistakes do happen. So you see how I've got x squared plus 6x plus 8. You might have been telling yourself, hey, Mr. Ham, that's wrong. And it is. So x plus 2 times x plus 6 back here, right? So when we multiplied those, we shouldn't have gotten x squared plus 6x plus 8. What we should have gotten was x squared plus 8x plus 12. So do keep an eye on your multiplication, right? Don't be sloppy with your foiling like I was. And so when we come back here and we do this last bit, we should actually have 2x squared plus 16x plus 24. So that looks a little bit better. So if you incorrectly copied that down, my apologies. Do make sure you change it now. And so we've got our common denominator down there. And okay, that's a whole bunch of terms. So when you're combining your like terms here, be really, really careful. I'm going to color code things. You can rearrange them to get them kind of grouped up. You don't have to. You could just start adding. Just be really, really safe with it. So we've got x squared, we've got minus 3x squared, and we've got plus 2x squared. Then we've got plus 6x, plus 5x, minus 22x, and plus 16x. And then the 10, the minus 24, and the plus 24 all go together. So looking at our x squared minus 3x squared plus 2x squared is actually just going to all cancel out. So that's going to be 3x squared minus 3x squared. So we've got no x squares. For my x's, 6 plus 5 is 11. 11 plus 16 is 27. And then 27 minus 22 is 5. So for me, I'll typically do all my adding and then worry about the subtraction at the end, like I just did. And then for here, 10 plus 24 and minus 24, well, those 24s are going to cancel out, and we're just going to get 10. So we've got 5x plus 10 over our denominator of x plus 2 times x minus 6, or x plus 6. And so suddenly this one became way simpler looking. We can factor out up top, so we do have a common factor. We're going to take out the 5. It's going to leave me with x plus 2. And that is going to cancel out with the x plus 2 in our denominator, which is going to get us our final, much simpler looking answer of 5 over x plus 6. Our NPVs, our x cannot be negative 6 and negative 2. So there's a lot of work that goes into that, right? So there's a lot of places to mess up, as you saw, right? I did make a mistake. Mistakes do happen, but you want to try to make sure you don't make them. So you've got to take your time, do everything really carefully, and make sure you're getting all your numbers down properly. All right, one last question that's going to be quite a bit different from these last ones, but is going to seem really hard at first, but won't actually be as difficult as it looks. So we got 3 plus 1 over x over 2 over x plus 5 over x squared. So that looks awful. We've got fractions inside of fractions, which is never something we like to see. So my advice, if you're confronted with anything like this, is to kind of break this apart and to simplify the numerator and denominator separately. And then we'll worry about the larger fraction later. So for our numerator, we've got 3 plus 1 over x. And that doesn't look too bad, right? That's pretty simple. So to make this something we can work with, we probably want to put a denominator under that first fraction. So we're going to turn that into 3 over 1. And then our common denominator for 1 and x is just going to be x. So our first fraction needs to get multiplied by x. And so now we've got 3x over x plus 1 over x, which when we put them together is just going to be 3x plus 1 over x. So that wasn't too bad. We're going to do the same thing with the denominator of our original question. So we've got 2 over x plus 5 over x squared. Our common denominator here is going to be x squared. So our first fraction needs to get multiplied by x again in this case. And so this is going to be 2x over x squared plus 5 over x squared, which when we put those together, we're going to get 2x plus 5 over x squared. And so the key thing to remember, if we put all of this back together, it's not actually going to look much better at this point. We're going to have 3x plus 1 over x over 2x plus 5 over x squared. And so that, to me, actually kind of looks worse than what we had before. But the important thing to remember here is this division, or this fraction rather, in the middle is just division. And so instead of writing this as a really, really big fraction with fractions in it, a better way to think of this would be to think of it as 3x plus 1 over x divided by 2x plus 5 over x squared. And we know how to handle division, right? We did a video on this. You may have done a lesson like this in class. So to work with division, well, we're going to change it into multiplication. So we need to flip that second fraction. So this is going to become 3x plus 1 over x times x squared over 2x plus 5. We can simplify those x's a bit, so that x in the bottom left is just going to cancel out. The x in the top right is going to go from x squared to just x. And so we're left with our final answer of x times 3x plus 1 over 2x plus 5. For MPVs, we've got that x can't be 0 and x can't be negative 5 over 2. And so yeah, anytime you run into a case like this, try to think of it as a division instead of as a fraction. It'll make your life hopefully a little bit easier. And so that's it for adding and subtracting. In this video, things got quite a bit more difficult, so do make sure that you spend some time to fully understand what was going on here. But the key takeaways are, well, factor, get a common denominator, get everything over that common denominator, combine things, and then simplify. So if you can get those steps down, you should be okay. In the rest of the chapter, through 6.4, we're going to be now using these rational expressions to work with equations. So once you're ready, go ahead and take a look at that.